Makaku stated that we will have to rewrite our textbooks on the beginning of the universe. Everyone has been waiting for this one image, which has finally been released to the public. The image from the James Webb Telescope shows unusual processes in the cosmos that once again challenge our science. Since the launch of the telescope, not only have our previous theories of the beginning of the universe been put to the test, but now the exoplanets are also going crazy and turning our ideas of physics completely upside down. What is the new situation, and what answers can scientists find to this new provocation? These days, we are experiencing a complete upheaval of the old rules in science. A telescope called James Webb is sweeping our old ideas of the universe off the table, and every image presented by this marvel of space exploration is a hit. James Webb, the telescope's namesake, would have been proud. Webb was head of NASA for a long time, although he was not a scientist himself but came from a business background. Webb knew how important it would be for mankind as a whole to explore space. In the 1960s, Webb pushed space travel enormously, launched the Apollo program, and advocated for space probes. Today, scientists are amazed at what the telescope named after this pioneer of space exploration can do. Images are so clear and sharp that they take our breath away. For the first time, we are holding complete analyses of exoplanets in our hands, some of which are thousands of light years away from us. Webb is relentless, showing our scientific community that they have been resting on their old findings and ideas for too long. At first, many scientists are also experiencing uncertainty and a queasy feeling. These days, everything they believed in could now turn out to be wrong. Mio Kaku, the popular astrophysicist from the USA, is one of the researchers who is sanguine about the new developments. Kaku has long postulated that our previous theories were incomplete. The fact that we have never been able to unite the world of subatomic quantum particles with the world of formed matter alone shows that we have not understood fundamental processes in the universe. Now exoplanets are also breaking the laws of physics. It's crazy. At first, it was only galaxies that were so old that they didn't fit into our cosmological picture. Then came black holes and gigantic structures that existed more than 13 billion years ago when the universe was supposedly still in its infancy. Now, even with the planets, nothing is as it once was. The latest images from the James Webb Telescope show us a series of exoplanets that turn our previous ideas about planets upside down. James Webb re-examined some of the strangest known exoplanets with his keen eye and his unique arsenal of spectrometers. These instruments break down even the smallest light signal into its individual parts and analyze traces of elements, gases, evidence of water, and parameters that allow conclusions to be drawn about the size and orbits of distant planets. In the process, Webb finds more and more anomalies, extremes, and the craziest planets. One remarkable example of these impossible worlds that defy the rules of physics is KLT9b, an ultra-hot Neptune orbiting so close to its star that the temperatures on its surface are high enough to split water molecules into atomic hydrogen. The extreme proximity to its star further leads to a phenomenon scientists call atmospheric blow-off. The planet's atmosphere is literally blown away from the star. This discovery is unique among all planetary atmospheres known to date, and for this reason alone, this planet is a challenge. Webb finds so many exceptions and extremes that it's statistically impossible. This planet is so strange that it's practically impossible to classify, and it's a particularly blatant and difficult to explain exception to all the rules we humans have created. Let's take another look at a world that terrifies scientists. WASP-76b, a giant exoplanet with iron raining from the sky on its night side. The planet orbits its star in a bound orbit and thus has an extremely hot and cold side. The metals that are melted and vaporized on a hot day side solidify into iron on the far side of the planet and then fall to the ground like rain. Once again, scientists are dealing with extreme conditions that impressively demonstrate the physical processes on exoplanets and create more questions than answers. Particularly fascinating and puzzling is the discovery of planets orbiting their stars in the opposite direction to other planets in the same system. Such a discovery forces astronomers to rethink theories about the dynamics of planetary systems and the forces that determine their orbits. WASP-17b is an example of such a crazy world. This planet was found as part of the wide-angle search for planets, WASP for short. This exoplanet is a huge gas giant that looks a bit like our Jupiter but orbits its star in a retrograde orbit, which means that its orbital direction is opposite to the rotation direction of its star. Until now, this was considered scientifically impossible. According to current theories of planet formation, all planets in a system should orbit their star in the same direction as they evolved from the original protoplanetary disk. One theory that explains such orbits is that gravitational perturbations from nearby passing stars or other massive planets in the system can dramatically alter the orbit of a planet after its formation. Another possibility is that a gravitational dance between several large planets can cause one or more of them to be pushed into a retrograde orbit. When we look for crazy planets, we don't have to look beyond the boundaries of our solar system. In the Kuiper belt, we find the dwarf planet 2007 or 10, which scans have shown to be unusually dark and red. Scans with Webb spectrometers show that this planet is probably rich in complex organic compounds that scientists call tholin. Despite its considerable size and peculiarity, 2007 or 10 has so far remained without an official name because the planet's exact orbit has not yet been determined. The probable composition, organic substances that are ultimately the building blocks of life, and the unusual color do not fit the picture of the other dwarf planets in the Kuiper belt. Where does this planet come from? How did it form, and why is it so hard to see? Due to its great distance, it's extremely difficult to observe 2007 or 10 accurately and over a long period of time, even with our best telescopes. 2007 or 10 is possibly the third largest dwarf planet after Pluto and Eris. Researchers see it as an important key object for understanding the dynamic processes in the Kuiper belt and the evolution of the entire solar system. Planets without a star. Is that possible? Would you have believed that there are planets without a star? Planets actually form in the dust and gas left over from the birth of stars, and then they remain gravitationally bound to their star, or so you would think. However, vagabond planets show that this does not always have to be the case. Such planets are cosmic wanderers without a star that drift freely through space. But where do they come from, and how can they survive in the hostile cold of space? Vagabond planets can form in different ways. One common way of formation is ejection from their original star system. This can happen through dynamic interactions with other planets or close stellar flybys, where the gravitational forces are strong enough to pull the planets out of their orbit. Another possibility is that they were formed as isolated objects in a star-forming region, similar to stars but without sufficient mass to initiate nuclear fusion processes. This could also explain the existence of objects like Jupiters. For example, Jupiters are Jupiter mass-like objects. As the name suggests, they are similar in size and mass to Jupiter, which is itself considered to be an obstructed star. Jupiter, the largest planet in the solar system, would not have lacked so much mass that it could have started nuclear fusion processes itself. However, the necessary little bit was missing, and so it only became a planet. James Webb shocked the scientific community once again when the telescope discovered 80 such vagabond Jupiter-like planets in the Orion Nebula. The really bizarre thing about this discovery is the almost unbelievable fact that these 80 Jupiter-like planets have formed 40 binary systems. This means no less than that there are 40 vagabond pairs of planets orbiting each other in a relatively confined space within the Orion Nebula. This is bizarre and actually scientifically impossible. The mere existence of so many Jupiter-like planets may, of course, be due to the fact that the Orion Nebula is one of the most intense star-forming regions we know of. However, more detailed investigations then showed that the planets are not really planets at all but are somewhere between planets and brown dwarfs in terms of mass. Of course, this suggests that they are prestellar objects because brown dwarfs are among the smallest stars we know of. But what processes in the Orion Nebula are responsible for prestellar objects, which somehow act like planets dancing freely through the cosmos in binary systems? The mechanisms behind this are once again an extreme challenge for our scientists. They are probably a class of objects in their own right, and this finding once again pushes the boundaries of our astrophysics. It is possible that such massive free-flying objects are much more common in the universe than we thought. They could be normal but are unusual for us because we were previously unaware of the phenomenon. We have not been able to detect exoplanets in the depths of space for very long. Studying them more closely has long been a challenge, and the James Webb Space Telescope represents a milestone in this respect. We are now naturally thrilled by such discoveries, but scientists are slowly becoming overwhelmed by the new phenomena and impossible discoveries. Nothing is as they thought it would be. Has science come to an end? Did you know that the James Webb Telescope is said to have caused a scientific crisis in astronomy? The fact that James Webb opens our eyes to a universe that contradicts our previous knowledge is actually an indication of how much our previous theories have missed the true state of the universe. Are the findings of the James Webb Telescope simply not confirming the theories we already had? Instead of closing gaps, the findings are tearing new holes in the constructs we call truths. Some are saying these days that the crisis Webb has triggered is the end of our old science. As Miyokaku has already said, we will have to rewrite our textbooks, but what do we write in them now? No coherent new answers have yet been found, and researchers are desperately looking for new explanations. We may have to say goodbye to the idea that our astrophysics and cosmology can really unlock the secrets of the universe. The James Webb Telescope represents not just a technological marvel, but a window into the deepest reaches of the universe, where phenomena once thought unimaginable are now becoming reality. With its unprecedented capabilities, James Webb has opened our eyes to a universe that challenges our fundamental understanding of physics, cosmology, and the origins of celestial bodies. One of the most intriguing discoveries made possible by James Webb is the observation of extreme exoplanets that defy conventional planetary models. Take, for instance, the recent findings on Kepler-10b, an exoplanet located about 560 light-years away from Earth. Kepler-10b is an extraordinary world with a mass 4.6 times that of Earth and an incredibly hot surface temperature of about 2,500 degrees Fahrenheit. Its discovery challenges existing theories about planetary formation and the limits of habitability in the universe. Moreover, James Webb's observations have provided unprecedented insights into the chemical compositions of exoplanet atmospheres. By analyzing the light passing through these atmospheres, astronomers can detect the presence of various gases and elements, offering clues about the planet's origins and potential for hosting life. This capability has already led to the discovery of water vapor in the atmosphere of several exoplanets, including some that reside within their stars' habitable zones. Beyond exoplanets, James Webb has also revolutionized our understanding of star formation and evolution. The telescope's ability to peer through cosmic dust clouds has revealed intricate details about the birth of stars and planetary systems. By studying young stellar objects in regions like the Orion Nebula, astronomers have gained insights into the processes that give rise to stars and the formation of protoplanetary disks, a crucial step in the creation of planetary systems. Furthermore, James Webb has contributed significantly to our knowledge of galaxy formation and evolution. By observing distant galaxies billions of light-years away, the telescope has captured light that has traveled across the universe for eons. These observations provide a glimpse into the early stages of galaxy formation, offering clues about the conditions that existed shortly after the Big Bang. One of the most astonishing findings from James Webb's observations is the detection of galaxies that formed just a few 100 million years after the Big Bang. These ancient galaxies, known as first-light galaxies, represent the earliest structures to emerge in the universe. Studying them allows astronomers to investigate the processes that triggered the formation of stars and galaxies in the early universe and to trace the evolution of cosmic structures over billions of years. Moreover, James Webb's observations have shed light on the mysterious dark matter and dark energy that dominate the universe's composition. By studying the gravitational effects of these invisible substances on the motions of stars and galaxies, astronomers can infer their presence and distribution throughout the cosmos. This research is essential for understanding the underlying forces that shape the large-scale structure of the universe and drive its expansion. In addition to its scientific discoveries, James Webb has also sparked renewed interest and enthusiasm for space exploration and discovery. The telescope's breathtaking images and groundbreaking findings have captured the public's imagination and inspired a new generation of scientists and engineers to push the boundaries of human knowledge further. Looking ahead, James Webb's mission promises even more groundbreaking discoveries as it continues to explore the universe's depths. Planned observations include studying the atmospheres of potentially habitable exoplanets, mapping the distribution of galaxies across cosmic time, and unraveling the mysteries of star formation in distant galaxies. However, James Webb's journey has not been without challenges. The development and launch of the telescope have involved years of meticulous planning, engineering innovations, and international collaboration. From overcoming technical hurdles to ensuring the telescope's precise alignment in space, the mission has required the collective efforts of thousands of scientists, engineers, and technicians from around the world. Despite these challenges, James Webb's successful deployment marks a triumph for international cooperation and scientific achievement. It represents a testament to humanity's insatiable curiosity and our relentless pursuit of knowledge about the universe's origins, evolution, and ultimate fate. In conclusion, the James Webb Space Telescope stands as a beacon of human ingenuity and exploration. Its groundbreaking discoveries and technological advancements have forever changed our understanding of the cosmos and our place within it. As we continue to explore the universe's vast expanse, James Webb will undoubtedly lead us to new discoveries, unraveling the mysteries that have fascinated and perplexed astronomers for centuries.